guys, welcome back to my channel. Today I'm going to be talking about geometric series. So geometric series. And with a geometric series, it's a series, so you're summing things up. So you will start with A, okay? And then you're gonna add A times R, and then you're gonna add A times R squared. Then you're gonna add A times R to the exponent of 3, and so on and so forth, right? So you see you're multiplying by R each time. So multiplying by R, because here was no R, now there's R here, and there's R squared here, but there was only R to the exponent of 1 here. So you're multiplying by R each time, and then it goes all the way to A times R to the exponent of n minus 1. And this basically looks like this if we put the summation symbol. A times R to the exponent of n minus 1. So basically this is a geometric series, and with a geometric series we want to know if it converges or diverges. And to tell as to whether it converges or diverges, we look at the R, which is called the common ratio. So in this case we look at the absolute value of R, okay, and we see as to whether it's greater or less than 1 or equal to 1. So if it's less than 1, it's going to mean that this series is going to converge, so it's going to be convergent. However, if the absolute of R is either greater than or equal to 1, then it means that the series is going to be divergent. And if R, the absolute value of R, is less than 1, it means it's convergent, then that means there's going to be a sum. It's going to approach some sort of sum, right? It's going to approach some sort of sum when n goes to infinity, and that sum is going to be found from this equation. The sum is going to be equal to A over 1 minus R. So the A and the R's are from here, right? Or from here, and you could sub it in and you can find the sum. Okay, so say now we have a series that looks like this, and we are going to have to determine as to whether it converges or diverges. We don't know, so we're gonna have to find out. And to find out is we have to make the series in the form of a geometric series. So geometric series, recall, has the form that looks like this. So we're trying to change this geometric series into this type of form. So here we have n minus 1, but here we have n plus 1, and we have 3n here. So we want to try to change the exponents to n minus 1. And to do that, we can first see that we can see that n plus 1 can get distributed into this negative and the 7, right? This is actually, if we were to write this, be negative 1 times 7 all to the exponent of n plus 1 over 2 to the exponent of 3n, right? But let's write the n out like this so we can manipulate with it later. So here we can see that we can distribute this n plus 1 into each one of these. So negative 1 is going to get n plus 1, 7 is going to get n plus 1, right? We're distributing this exponent to each one of these, right? The negative 1, by the way, came from this negative, so that's why we can write that. And then here it's 2 to the exponent of 3, which is going to be 8 to the exponent of n. And then we can do next. So what we can do now is we can see that this is going to be negative 1 to the exponent of n times negative 1 to the exponent of 1, this part, because n plus 1 here, right, we're using exponent laws, it's going to give us n plus 1 right here, so we can do that. And same here for the 7 to the exponent of n times 7 to the exponent of 1, like that, so we can add these exponents together. We're kind of undoing that part. So this whole thing gives us this, exponent laws. This whole thing gives us this, because we're adding the exponents. Adding the exponents gives us this. then plus 1, and plus 1. So here, 8 to the exponent of n. How about we try to change this exponent of n to n minus 1? And to do that, we can basically minus 1 and add 1, because if we have 8 to the exponent of n, right, it's basically equal to 8 to the exponent of n minus 1, add 1, because if we cancel these out, we get 8 to the exponent of n. So let's do that. So that's how we incorporate that minus 1 portion into here, right? That's why we did that. So now what we're going to do is we are going to do the same thing with the minus 1 plus 1 for this negative 1 and for the 7 as well. So we're going to do that. First, before we do it, let's write out these parts together so we can kind of make it less confusing. So this part and this part right together, kind of separate it. And then we have these ones, right? Negative 1 to the exponent of n, and we also have 7 to the exponent of n from here, right? And then let's do that trick. So minus 1 plus 1, minus 1 plus 1, like that. And then here it's also 8 to the exponent of n minus 1 plus 1. Well, we can separate this, right, as 8 to the exponent of 1 times 8 to the exponent of n minus 1. And that's because this 1 gets added to n minus 1 to get this. So we're kind of undoing that so we can get ultimately this form with n minus 1. So we try to get rid of all the other stuff so we can get the n minus 1. We're going to do the same thing at the top here. So doing the same thing on the top, well here negative 1 times 7, let's combine these together, negative 7. Let's combine the 8 as well, so it's going to be negative 7 over 8 that we have here. Right, so we got rid of this part. Now we have to work on this part, right, with the ends. So here it's going to be, let's write the fraction line, it's going to be negative 1 to the exponent of n minus 1 times negative 1 to the exponent of 1, right? Adding 1. We take these two exponents, add them together, we get this ultimately. Same thing for the 7, so 7 to the exponent of n minus 1 times 7 to the exponent of 1. Take these two exponents, add them together, we ultimately get this. Okay, so we're separating the 1 out, right? So that way we can get n minus 1 as shown in this form. So we got rid of the 8, we put it here, we got rid of the negative 7. Okay, now we're just left with n minus 1 for this 8 to the exponent of n minus 1. So right here. And then now what we can do next is we can take these exponents of 1 and bring them outside as well. So we can just isolate for the n minus 1. So negative 7 over 8 times, let's put all of this stuff here in this bracket. So this is going to be negative 1 times 7 to the exponent of 1, which is just 7. So we got rid of this and this part. And then now for this part, negative 1 to the exponent of n minus 1 times 7 to the exponent of n minus 1. Right, this part and this part we put here. And then 8 to the exponent of n minus 1. Take this part, put it here. This is in the denominator. So we got this part, this part, this part. It's negative 1 is here, 7 here, good. And we copy this, good. We got everything. Now the next step is we can combine these together, right? So negative 7 times negative 1 times 7, right? It's like saying negative 7 times negative 7. It's going to give us, well, two negatives make a positive, so it's going to be 49. And then here it's over 8, so we copy that over 8. We get this part, and then this part, we can take this n minus 1, right? We can combine it together with n minus 1 outside of the brackets, and then here everything is inside, like this. So that way we can kind of get like this format, right? That's what we ultimately want. So we combine all this n minus 1, and we put it like that. And that's because, well, why can we do this? It's because of exponent laws. Once again, we can take these and combine it together, and then that's how we get this. So now we can look at this and say, oh, it's 49 over 8. This is like our a, okay? And then here, let's just combine these together. -1 times 7 is going to be -7, and then this is over 8. Then to the exponent of n minus 1. Okay, so we did get this one. We got this format, right? Recall the format looks something like this. If we were to compare it side by side. So it's this format. Now, if we look at this format, this is going to be our a, right? This part's going to be our a. This part's going to be our r. So, because if we match it up, this is our a, right? This is our r, and then r to the exponent of n minus 1, right? So, a is going to be equal to 49 over 8, and our r is going to be equal to -7 over 8. So now we have to see whether this series converges or diverges. And to tell whether it converges or diverges, we look at the absolute value of r. Now, r is equal to -7 over 8, so our absolute value of r is going to be equal to the absolute value of -7 over 8, and that's going to be equal to simply 7 over 8. And 7 over 8 in this case is less than 1, and recall that if r is less than 1, then that means it's convergent, right? That means the series will converge. And in this case, our r is less than 1. This is true, okay? So since this is true, we can say that therefore the series is convergent. And we can also find the sum for this series, right? Because it's convergent, and recall that to find a sum of a geometric series, all we have to do, this is the sum s, represented by s, we just have to take this a over 1 minus r. So in this case, our sum is going to be equal to, basically we sub in our a is going to be 49 over 8, so we write in 49 over 8 all over 1 minus r. Our r is going to be equal to -7 over 8. Sub in -7 over 8, and then here we just have to simplify the denominator, so let's write in the numerator. Denominator here, let's make a common denominator, so 8 over 8. This is negative, double negative, positive, plus 7 over 8. And then next step is we can add the denominator. So 8 plus 7 is going to give us 15, so 15 over 8. And then let's flip the fraction, right? Because we have division here, and to divide, all we have to do is we just have to change it to multiplication and flip the second fraction. So 49 over 8 times, it's going to be 8 over 15 instead, and this 8 and 8 is going to cancel, and we ultimately end up with 49 over 15 as our sum in the end. So therefore, the sum is equal to 49 over 15 for this series. Okay, so this is the end of my video. Thank you for watching, and I hope you enjoyed it. Feel free to let me know in the comments down below what you think about this video, and feel free to like it if you like this video, and feel free to hit that subscribe button if you are new to my channel. Alright, thank you for watching! I hope to see you next time for another one of my fun math videos. Bye guys!